The terrible floods in India's tiny North Himalayan state of Uttarakhand, which killed more than 1,000 people, left 70,000 stranded for days, and destroyed livelihoods, have been officially termed a natural calamity caused by cloudbursts and unprecedented heavy monsoon rainfall. These man-made factors turned an extreme weather event into a social catastrophe. True, the region experienced heavy rainfall of 340 to 370 millimeters within 24 hours on June 16th through the 17th, leading to flash floods. But such precipitation isn't unprecedented. Uttarakhand has recorded single-day rainfall in excess of 400 millimeters several times, including 450 millimeters in 1995 and 900 millimeters in 1965. Cloudbursts, floods, and rapid swellings of fast-flowing rivers aren't uncommon. But this time, the floodwaters that contained a lot of silt, boulders, and debris from dam construction found no outlet. The routes they took in the past, including ravines and streams, were blocked with sand and rocks. The waters were inundated scores of towns and villages, submerging some buildings under several feet of mud, smothering life. Aggravating the devastation were two downpours of water and rock from the higher mountain ranges, in all probability caused by glacier lake outburst floods, GLFOs, which deluged the Kedarnath temple, a major Hindu pilgrimage center. GLFOs, or the explosive bursting of glacier lakes, are thought to be a consequence of human-induced climate change, which is caused by rapid melting of glaciers in the Himalayas, themselves warming at twice the global rate.
Such a massive loss of life could have been greatly reduced if an early warning system, effective evacuation plans, and a responsive disaster management system were in place. They weren't, and in fact, as the Comptroller and Auditor General pointed out in April, the Uttarakhand Disaster Management Authority, formed in October of 2007, has never met or formulated regulations, policies, or guidelines. Modestly priced radar-based technology to forecast cloudbursts would have saved lives, but it wasn't installed, nor were emergency evacuation plans drawn up. There was local level government failure too. Haphazard, unregulated constructions of roads and bridges was allowed on crumbling, landslide-prone ridges and steep slopes. Ignoring the region's fragile geology and high earthquake vulnerability, forests were destroyed on a large scale. Hundreds of buildings were constructed in the flood. Plains of rivers, their natural terrain, which should be no-go areas, were built on. Riverbeds were recklessly mined for sand. As construction debris accumulated, land contours and flows of streams and rivers changed. Indiscriminate building of hydroelectric dams was the worst culprit. These involved drilling huge tunnels in the hills by blasting rocks, placing enormous turbines in the tunnels, destroying soil-binding vegetation to build water channels and other infrastructure, laying transmission lines and carelessly dumping evacuated muck. Many dams have been built on the same river so close to one another that they leave no scope for its regeneration. Dams steal water from local people. They alter the hydrological cycle and natural course of rivers. Uttarakhand's 70 completed large dams have diverted more than 640 kilometers, equivalent to half the length of its major rivers. They have profoundly disestablished its ecology. Yet another 680 dams and reportedly in various stages of commissioning, construction, or planning, mainly by private companies, which would be largely unaccountable. A 2009 report complained that the government was pursuing hydropower products indiscriminately, ignoring the damaging cumulative effect of multiple run-of-the-river dams. Technically, India's Environment Ministry follows an environmental impact assessment process, but that's badly compromised by the Indians' elite's insatiable appetite for electricity and promoters' pressure.
When viewing the destructive catastrophe as a whole, it can be noted that there were many influences that played key roles in why and how these floods and landslides became major hazards for the residents of northern India. A combination of warming climate, early heavy rains of the monsoon season, isolated locations of areas affected by the hazards, and large amounts of biomass blocking streams and rivers all contributed to the deadly forces which destroyed many structures. It also led to the uprooting of landscapes and took the lives of many North Indian residents in the summer of 2013.